about quadratic formula, here is what you should have done. On number 1, it was 3x squared minus 5x plus 1 equals 0. Remember, it's equal to 0 because we're looking for those x-intercepts. This is saying if y is 0, what is that x-intercept? It's already in standard form. We talked about that the other day. Make sure you keep your signs, then we can plug it in. B is already negative, right? So what happens to it? Becomes a positive. Plus or minus the square root. Remember, we always put that squared number in a parentheses. 4 times a times c all over 2a. Is there anyone who doesn't understand where these numbers came from? When you put this into the calculator, 25 minus 12 is 13. So now I have x equals 5 plus or minus the square root of 13 all over 6. Now, remember, this is your discriminant. It is a positive number. If the discriminant is positive, how many roots are we going to have? 2. Does this simplify? No, this does not simplify either. You are actually done. Now, you could change those to decimals if you wanted and graph it and see if it matches to check your work if you wanted. But at this point, as far as simplifying, we are finished. How did you do on this one? All right, nice job. Number 2 was not in standard form. Did you change it?
Is the formula just going to be on the
This formula? Yes, the one that I put the little rhyme on the video the other day for, this is on your formula chart. You do not have to memorize this. Okay? So don't feel like you have to. But you do have to put this in standard form, meaning you need to move everything to one side. So did you do that first? You got x squared plus 8x minus 6 equals 0. Did you get that? All right, if you don't change it, and remember, standard form is also on there. So you need to make sure you get it there, right? That's your standard form. So when we plug this in, now A is 1, B is positive 8, and C is negative 6. You need to make sure that you keep those signs, and then you can plug into our quadratic formula up here. Right, I'm going to write over here because I need a little bit more room for this one. X equals negative B. B is positive. It's going to become a negative. Plus or minus the square root. I'm going to always put that number in parentheses, because when you put that in the calculator, if you don't put this in parentheses, especially if it's a negative, it's going to mess up, okay? How did we do on this one? Did you set it up correctly? Then you can take to your calculator, you can plug in your numbers for your discriminant. So I'm going to say 8 squared minus 4 times 1 times, don't forget to put a negative on that 6, I get a positive 88. Now, did anyone leave that a positive 88? We know that we have 2 roots. This simplifies. If you stopped here, you're not quite done. Okay, 88, remember, is 4 and 22, which is 2 and 11, which is 2 and 2. Here's my pair. You can also, if you recall, menu 2, 3, 2 times 2 times 2 times 11, right? Where do the pairs go? They go outside. So I'm going to say negative 88 plus or minus 2 on the square root of 22 all over 2. Again, if this is multiple choice, you're like, woohoo! And that's not an answer, because we're not done simplifying. You're getting there, but you haven't simplified it all the way. Can we take and simplify negative 8 and over 2? What do we get? Negative 4 plus or minus, can I simplify 2 over 2? 1. They're not going to write the 1. If you want to write the 1, you can. On the square root of 22. Now you are finished. 22 does not simplify. It's just 2 and 11. So you're done. I know you're like, it's even. I really wanted to simplify. When you're simplifying this denominator, you're not going to simplify it. You can't simplify it on a radical. If it was the square root of 22 over the square root of 2, yes. But if it's a whole number, or an integer in a radical, can't do it. All right. Shall we look at 3? 3 was nice and pretty set up for you. We have A is 1, B is 5, C is a negative 1. So x equals negative b plus or minus square root of b squared minus 4 times a times c. Be very careful with those signs. All over 2a. Did you get that set up correctly? Yay. I think you guys were a little intimidated by that, by the formula, but the setting up is actually not that bad. So negative 5 plus or minus. All right, this is 25 plus 4 is what? 29. Does 29 simplify? No, you are finished. If it doesn't simplify, you're done. Who got that one? Anybody? Very nice job. If you didn't, go ahead and write it down. Fix whatever you need to because you're going to do one for a grade. 4 was already set up for you. All right. Again, be careful with those symbols because that's where people get in trouble. If you mess up a sign, it's going to blow up your whole problem. X equals, so this is a negative. What happens to it? It becomes a positive. Negative 1 squared minus 4 times negative 2 times 4 all over 2 times a negative 2. So when we do this, we get 1 and a positive 8 is 9. Can we take the square root of 9? We can't? What's the square root of 9? 3. Did I do that right? I don't think I did that right. Oh, I forgot my 4. So no, this is not 9. Nobody caught it. Did you see what I did? I thought that I'm so used to A being 1, I didn't even look at the C. So let's try that again. Negative 1 squared minus 4 times negative 2 times 4. 33. There we go. Does that simplify? No. So can we do anything else? No. Isn't it? It's actually kind of nice when you can't do anything else, right? Not as much work. 5. 5 was almost in standard form, but what did you need to do? Move the 1. How do we move the 1? Minus 1. So this becomes a negative 3, right? So A is 4, B is negative 5, C is a negative 3 now, yes? Negative, negative B becomes a positive. I'm not sure why I put it equals there. Plus or minus the square root, and we have negative 5 squared minus 4 times negative 3. Let's see if I do it right this time. Over 2 times 4. So you know that this is 25 minus 4 times negative 4 times a negative 3. And we get, oh my goodness, negative 23. I don't think that's right. Your soccer number is negative 23? Where did I go wrong? Oh, I put a negative. Look. All right. So all things detail-oriented. Look, I put this as a negative and it's not. That's why it didn't work. If this was a negative 23 underneath the square root, what would that mean? Yeah, it would be no solutions. Okay, 73. That looks better. So we have x equals 5 plus or minus the square root of 73 over what? 8. Does 73 simplify? No, it does not. How are you doing so far? You're following along? That's good. If you have a question, I need you to let me know. The simplifying part can really get to you. So this one, you had to do some simplifying. Let's see how you did on that. Minus x plus 1. Yes, putting it all together is where it gets tricky. So that's why we have to practice it. Did we get this for the standard form? You got A is 1, B is a positive 4, and C is a negative 1. Did you get that? Because if your signs are wrong, it's not going to work. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times a negative 1. all over 2 times 1. 16 plus 4 is 20. Does that sound right? Negative 4 plus or minus. Oh, what do we know about the square root of 20? It can. We can say it is 2 squared times 5. So I have a pair here. Where does that go? That goes outside. So I have x equals negative 4 plus or minus 2 on the square root of 5 all over 2. Okay, so again, when it simplifies, it gets a little more complicated. Can we simplify this?
Yeah.
What do we get? X equals negative 2 plus or minus, can I simplify this?
Yeah.
I get 1. You don't have to write it. You can on the square root of 5. Okay? And again, when we put that in if we change that to a decimal and we graphed, it would be the roots. 7. You got to move everything over. 3x squared equals negative 6x plus 4. So we're going to add the 6x and minus the 4. 3x squared plus 6x minus 4 equals 0. So A is 3 and B is 6 and C is negative 4. Be careful when you plug it in. All right, the square root of 6 squared minus 4 times 3 times a negative 4 all over 2 times 3. So again, it sounds like most of you have that set up. All right, 36 minus 4 times 3 times a negative 4 is 84. Ugh, that's ugly. Negative 6 plus or minus the square root of 84 over what? 6. So I'm going to use my menu 2, 3 because that just makes life easier. And look, I've got a pair. Where does this pair of 2's go?
Outside.
What's going to be inside?
3, 7.
No.
21.
21.
Come on, Abide. Yeah, no.
Negative 6 plus or minus 2 on the square of 21 over 6. Am I done?
Nope. You have to divide.
We have to divide. We can simplify. So you can look at this as negative 6 over 6 plus or minus 2 on the square root of 21 over 6. Okay?
So we make x equals negative 1 plus or minus.
Plus or minus, keep going.
1/3.
1 on the square root of 21 over 3. Nice job. All right. Did you try 8 and 9? Are we okay? All right. So let's talk about what we're going to do today. All right. I want to do one more example with you because this one comes out very, very pretty. I know, right? We didn't have any a minute ago that turned out very pretty. So, first of all, we got to do what? We got to move it over. So we have x squared plus 3x plus 2 equals 0, yes? We got to move this 2 over. So my A is what? My A is 1. What's B? What's C? 2. Sometimes these come out really, really nice. All right, so if I plugged it in, I get negative 3 plus or minus the square root 3 squared minus 4 times 1 times 2. All over 2 times 1. I know, I told you it's going to come out real nice, and you're like, yeah, that doesn't look real nice. It's super pretty. All right, so like I said before, it seems like most of us are very good at setting up, yes? All right, so let's see what happens when we simplify this. I've got negative 3 plus or minus. All right, you can use your calculator. You can do it in your head. All right, I get 3 squared minus 4 times 1 times 2. I get 1. That's not a mistake. It's actually 1. Okay, because this is 8. So I have 9 minus 8. So I have the square root of 1 all over 2. What is the square root of 1? So this is a perfect square, yes? Think back to Pythagorean theorem last year. So if this is a perfect square, I'm just going to draw a little arrow over here. Now I have -3 plus or minus 1 on the square root of 2. It is a whole number now. And way back when we first looked at this positive negative symbol, we said that is two operations. So this is really two separate problems. Yes? This is saying x equals -3 plus 1 over 2. And this is also saying -3 minus 1 over the square root of 2. Do you see that? So -3 plus 1 is a -2. What's a -2 over 2? -1. What's a -3 minus 1? -4 over 2 is -2. So our roots, our x-intercepts, they are very nice, -1 and -2. Do you see that? So if I go back, keep in mind what this means. If I go back to my calculator and I graph this standard form equation, right here are my roots, -2 and -1. Now, here's the thing about when it comes out really nice like that. I could have very well done the cross puzzle here and said x plus 1 equals 0 and x plus 2 equals 0, and I get x equals -1, x equals -2. But our purpose is the quadratic formula. But remember the quadratic formula when we talked on Thursday, you can use it for any of them. It's your 100%. Like when we did proportions in 6th and 7th grade, cross multiply divide is your 100%. Okay, the factoring, the completing the square, those are all your shortcuts. All right, does anyone have any questions right now? Do you feel pretty good? Better than you did? Are we still sideways or we go a little more thumbs up? Kind of? Okay. I want you to try. I have 6 practice ones for you. Some of them are not in standard form. So you're going to have to make them be in standard form. Some of them do have nice, pretty, perfect squares, so you'll get nice answers. Make sure you simplify all the way down, okay? Let's see what we can do. Go.